was hoping Carl would get that.
I'll give you like a 5-minute warning at the end.
Yeah.
But just so I don't forget to in case you miss me, I'm not going to waiting for a high five. When I stand up, you look over and you don't see me holding it, and you get your questions. Go whenever.
All right, folks, thanks for coming. If you were at Wolf's talk yesterday, I will say there's going to be a little bit of overlap here in that I am presuming arena, doing a lot of that and audit support stuff. And then the last 10 years or so, I've been working in the AppSec space. Primarily, a big portion of that is helping to set up AppSec programs, which is why I want to share some of that information with you folks. So that's been in a variety of industries, small places, big places, from places with like tens of applications to hundreds of applications and thousands of externally available IP addresses. Okay, so we're big diversity of stuff there, but I want to share some of that. So, and at Pondurance, I lead the AppSec space. So there, I work with this kind of thing, setting up software security programs for places, also doing threat modeling and secure architecture work for folks, and then we run, training stuff, especially around software security, and doing application security testing of all types, right? Pen testing apps, that kind of thing. So that's my space. That's who I'm about. For the room here, I recognize some of you, but not all of you. How many of you do development of some sort yourselves? Few, okay. How many of you are consultants? Okay. And let's see. How many of you have in-house software that you have developed or some team at your company has developed? Okay. How many of you have like third-party software that you get customized for you or anything like that? Okay. So generally, I'm staying away from the vendor side of this because that's a whole nother talk. I'll have a little bit on that. But most of the things I'll talk about today are applicable to vendor software as well. You just approach them a little bit differently, and we'll get into that for a little bit. But so don't think if you just have the vendor stuff that this doesn't apply, because it still really does. It's just a different approach, and we'll get into that. So I want to talk a little bit about some of the challenges we have and why people use like the SAM or BSIM and are talking more about building security in and avoiding just finding all the problems at the end and saying, oh no, what do we do now? So here's a fictional company. Let me know if this sounds familiar to you. So maybe you have a pen test every year. You talk to your software vendors and ask them questions like, how do we protect data? And what do you do? And maybe you do system vulnerability scanning for like OSs and things like that. And you do some sort of corporate-wide awareness training for security. It's not necessarily software focused. And then maybe if you're more advanced, you're also running like some sort of web app scans using dynamic testing on your apps, but usually probably after they're already in production. Does that sound familiar or like a lot of places you've seen? So what are some of the things so first of all, these are all great things to do, right? I'm not knocking any of this, but what I want to talk about is how we take this to an even more sustainable place and that sort of thing. So what are some things you would add to this list to do? Yeah. Software vendors lie. Okay, so something around the vendor management, doing more about that. Okay. What else? What else would you add? What's that? Monitoring? Yep. And I should say, because of the time we have here, I'm probably not going to get too far into the post-deployment activities, although we will do a little bit of that. But you're right, absolutely right. Other thoughts? Code review? Okay. Anything else? Okay, well, we'll step into it. We'll talk about a lot of things. And again, kind of using the SAM assumption, which is an OWASP project, if you're not familiar with it. It provides a system, a plan for doing software security lifecycle. But some of the challenges we have. So I want to talk about these first to kind of set the stage before we go into everything. One of them is timing, right? If you start testing your software too late, then you don't have time to fix it. You start it too early, you don't really have full enough product or mature enough product to actually have good results, right? So these are problems. We also know that unless they've been prepared, the people who own the software and are making the business requirements and want this pushed out haven't budgeted for you to do software security work, right? So that's a problem. And then we know that if you're manually validating stuff, that takes a lot of time, especially if you have to redo it all the time. So we're going to try to address some of those things. Any other timing issues you're aware of? Okay. And then there's a lot of data quality issues, especially if you're working with a lot of apps and a lot of tools and things like that. Almost every place I've been to, whether it was as a consultant or I worked on site, didn't have a real software inventory. Especially if there's been any acquisition or growth or the business bought or made software, things like that. So it's often a problem that we don't even know where all our apps are. So this is something that has to be combated. And maybe you're getting vulnerabilities from different sources, like tools you do, third parties tests, audits, and so you have these mismatched pieces of vulnerabilities in data. And then some of those don't have the dates you want for reporting. And that you don't have a good way to document the decisions you make as you're looking at these vulnerabilities and working with them. Any other quality issues you've run into in software security? No? Okay. And here's a big one, and I can't harp on this enough, because this is a really big problem with the interaction between people who have come to information security, especially not from a development background, and developers. We're not speaking the same language. And there's been a lot of problems because security folks are very arrogant about things. So we say things like, developers are dumb. See, they had a vulnerability, they're dumb. Or they just don't care about security. Or they're worried that we're just coming in to cop, like we're coming in to police things and that kind of thing. Or we use our jargon instead of theirs. Like we always say vulnerabilities, we don't say bugs, right? So these are some of the things we have to overcome. Developers care about quality, and security is an attribute of quality. And they're not dumb. They've been taught to do certain things, and they have certain business requirements, and they're meeting those requirements. So we've got to move away from that kind of language and think about where they're at and help them. Some other challenges we run into are in, like, how do we manage all the vulnerabilities? The cost of some of these tools and processes is big. We have repeat findings, third-party software, all these kinds of things. Any other challenges you want me to try to address if I get a chance today that I haven't listed already? Okay. All right. So most software security programs, if you try to start with too much and without planning, it's going to fail. And a lot of that is because it's a big effort, and if you don't have everybody on board, then things start to fall apart. Or you tick off people who are vital to the process, and they try to avoid you, or avoid the process, or work around it, that kind of thing. So I want to talk about, first, how you prepare a little bit if you're going into enhancing your software security program so that everybody can be involved appropriately. So my preference is to always start with your risk. And hopefully your organization already has done a risk assessment of some sort, either internally or you use a third party. It doesn't matter too much, but you want to understand your risk. What is the risk of the different apps you have and things like that, because that tells you where you should spend your money, right? You want to know what your SDLC is like. I've seen people try to bring like waterfall approaches to agile shops, right? And that just doesn't make any sense. You need to understand your SDLC, the tools people are using, et cetera. And scope that out according to these risk things that you've identified. You got to get buy-in from the right people. Again, you're not working in a security echo chamber. You're working with developers, you're working with the business, you're working with legal sometimes and compliance. Get all the right people on the team, and you got to get the funding for it. So some lessons from this. So first of all, like I said, that risk is really important. We all know that there is way more work in information security than there are qualified people to do it. And part of that we know is because the money gets spent on the wrong things. So one of the things we can do to help that trend is to do things based on risk. Where's the risk? Spend the money on the riskiest things and start there, right? So that's what's really important. Get the inherent risk for your apps if you can, and that tells you which ones need the most focus. You can have different rules for different apps and that sort of thing, depending on how complex you want to get. But it tells you at least where to start and what's important. Again, we talked about the SDLC, mapping everything to the tools appropriately. And scoping, as I mentioned before, start small. If you try to apply rules, like every app will do this before it goes into production, it's going to fail. There was too much overhead. Start small. So, get a few apps going and move on from there. And again, with support, you need to warn people about what's happening and get them involved so that they are prepared for the work that's going to go into this. So again, the point of all these preliminary steps is to make sure that if you're doing this program, your money is actually getting spent well, right? You're reducing the most risk for the least amount of money. And that's what we all want to do. So one of the background things to setting up these programs is education. We talked about the fact that there's this bad attitude that we have that, people just don't care about security or they're stupid or that kind of thing. And I think that's wrong. It's inappropriate and wrong. If you look out and how to code certain things, you're going to get flawed code examples. When I've looked at how to do SQL statements and stuff, over half of them end up being vulnerable to SQL injection, right? So that's a problem we have with the resources that are out there. So it's no surprise that we're writing bad code from a security perspective. So we need to equip people if we want that to change. And there's a little bit of talk about this yesterday. But basically, different people learn in different ways, but I want to talk about a few different resources that you can use. Software security training, that's obvious. We'll talk about that a little bit. But also writing secure engineering principles. When you're designing an application, what are things to take into account as far as that design? And then coding guidance. What are ways that we want people in our organization to code? And remediation guidance. Well, guess what? When a developer gets a finding from one tool and then another tool and they disagree, what happens? Anybody? They ignore both. Yes, they ignore both or try to code to the tool or just get frustrated and try to work around it. So we'll talk about that as well. So again, when you're talking about software security training, I'm actually talking about more than just your general awareness training. We're talking about teaching people about secure coding practices and that kind of thing, and how we're going to be integrating stuff into the SDLC. So I want you to think about not just the developers themselves, but people who have a piece of that software development process. People that write requirements, people that are in charge of the budgeting, Scrum Masters, project managers, folks like that. There may be a piece for them to learn as well. So getting all those people that are going to be affected by the security steps involved in the process to understand it. I got to give some credit on this slide to Aspect Security and Denim Group. They've done a lot of research around what works as far as software security training. And they've found that classroom training, one-on-one coaching, and e-learning are the most effective ways. So those are really recommended as your options. And use what works with your culture or a combination therein. They've also found that if you don't build in incentivization into your training programs, people just don't adopt it well. They won't do it, they'll avoid it, that kind of thing. So you can do this more positively, like reward drawings for people who get in or get by the right time or get done first or whatever. Or you can do it in other ways like, this affects your performance review or that kind of thing. But incentivize according to your culture to make sure it's getting done. And they've also found that if you don't do any refreshing on these topics, then they will be forgotten. So have some yearly or whatever interval works for you, refreshers, either on the most important things or things that have changed or things like that. And you can customize these per role, right? People who write business requirements need to know more about writing security requirements than they do about how to write secure C, right? So you can customize. And then we talked about principles and guidance and remediation guidance. The fact of the matter is, in your organization, there are going to be things that are different than what tools say, right? They assume a greenfield environment. Sometimes they conflict with each other, that sort of thing. And you're not in a perfect space. Maybe you are in a new app, but a lot of stuff isn't new apps. So customize these remediation guidance to your environment. This is the stack that we use. This is the fix that we use. You can go and get the code here because this is a validator that we've approved, right? Give that remediation guidance that's the standard for your organization and actually put that in the tools or reports that you provide to folks. Okay. We talk a lot about security testing, and that finds a lot of security bugs. But what it doesn't usually find is security design flaws, and that's like up to half of the bugs, right? Or half of the security issues with an app, sorry. So we want to talk about how to get some of that built in as well. So let's do that. So we've talked about some of these concepts in other talks this weekend, but threat modeling is a way of looking at the design of your apps, how things are set up to understand security issues there. We can write, based on the threat modeling and based on other things, security requirements. And then we can publish information about secure libraries and frameworks and make reference architectures. So let me step into those a little bit more. So the design review or threat modeling, the point here is to look at the architecture of the system, the data flow of the system. There's lots of different ways to do this. As other folks have said, you know, you can do the showstack method, you can do the Gary McGraw method. It doesn't really matter. The point is you want to do that design review from a security perspective because it finds things that testing tools cannot, right? They're design flaws, not coding issues. And that's important. So that'll either be something that needs to be fixed or needs to turn into a security requirement that you build into your project. And on the point of security requirements, the idea with those is we write requirements for projects because we know that we have to assign things to them. We have to be able to test them. We want to make sure that those are important things for the project. So we can actually write security requirements too. And those will take different formats. You know, maybe you're writing stories, maybe you're writing abuse cases and misuse cases, maybe they're traditional requirements, but do that according to your organization. But they are important because they make sure that the project actually gets attention for that. Another area is what we call components. So just like software inventory is hard, components is hard. What versions of various third-party libraries are you using? Do you have any idea? And a lot of those are probably full of holes. And it's a pain when you start doing things like static analysis and you're finding bugs and stuff that's not even yours. And the developers are saying, I can't fix this. This isn't my fault. Why are you yelling at my project for something that's third-party code? So what we can do with components is look at standardizing what third-party pieces we're using, building that into those architectures we talked about, and even using libraries that help us use standardized components. And there are some tools out there that help with this kind of thing too, like Sonar. But overall, we want to publish the best path for things like that, like components for reference architectures. Give people something to rely on. Don't just say fix it. Say here's something we know is good. And that makes it a lot easier for people to adopt what you're doing. So now everybody's favorite part, especially at conferences like this, we'll talk about security testing. How many people come from more of like a network security world versus an AppSec world? Just a few, okay. So in the network security world, when you're scanning stuff, you're mostly finding CVEs, right? Published known issues. When we're talking about AppSec, we're usually talking about CWEs. So they're not known issues, they're known types of issues, but new issues, right? So it's a little bit different. And we can integrate this type of testing into our processes in different ways. So let's talk about these different ones here. So dynamic testing is probably what a lot of people are really familiar with. These are scanning tools like WebInspect. There's AppScan that does this. You can do it with Burp even. So it's impersonating attacks on a live app, right? And with those, you need a running application, which means you need to be far enough in your development cycle that you actually have a running application. So that means you have to wait a little bit. But dynamic is good at finding certain things, especially like runtime issues, cookies, SSL issues, stuff like that. I'll skip over manual for a second and go to static. This is the other side that a lot of people use. This is actually looking at code or binaries, right? And that, you don't have to wait until you have a running app. You only have to wait until you have working code, right? And so that's going to be really deep. It's going to look at flow. It's going to look at patterns and that kind of thing. But because it's so deep, you also have a lot of false positives or unexploitable things. So there's some trade-offs. And then, of course, you have manual testing, pen testing, things like this. Testing the app with a subject matter expert's eyes. And that lets you find things that neither of these can find, and maybe only your design review would find. And these are all important. but you're going to have to pick what works well for your organization. You can do a combination, and sometimes you can actually do them together. Some of us actually will sometimes run dynamic scanners through an intercepting proxy, so we can see both what the scanner is seeing and what the proxy is seeing, and it's surprising sometimes that the proxy will find things that the scanner didn't. Strange, but it happens. So I want to talk a little bit about how you evaluate these, because it's tempting to say, okay, I'm going to purchase a dynamic tool or a static tool or even an integrated tool that looks at like runtime on the system. And I'm going to just see like how it does against WebGoat, and I want to see how many things it misses. But vendors who make these tools, they code to the test, right? So don't test against WebGoat, first of all, unless you have to. Test against one of your apps if you can, because they've prepared for it to look good against WebGoat or other projects like that. That's not going to tell you much. And further, I'd actually say that there's more important types of questions than just how much is it finding. Because how much is it finding is going to change over time. And the big, Gartner ones are going to kind of leapfrog each other over time. But ask some other questions as well, and I want to take a second on these. Of course, you want to look for support for your stuff, especially if you're looking at static. Is it going to cover the languages, libraries, frameworks, et cetera, you use? And it won't be 100% match, but try to look at your roadmap compared to theirs and see how it works. See how easy it is to triage the results. When you have false positives and things like that, how well can you deal with that? Is it easy? See how well it can remember your results markup. If you tell the system, no, this is actually a medium, will it remember that next time? And guess what happens if it doesn't? That's a pain, isn't it? For you and the developer and everybody else to have to redo that. Or if you say this is a false positive or not a risk or whatever, you want the tool to be able to remember that for you. That's a big deal if you have a large volume. How well can you customize the assessment rules? If you found out that something is a proper validator, you want to be able to tell the tool, if you see this, we're safe, right? Can you do that? Can you add a custom check for something that you know you don't want to happen in your organization, but they don't have a vulnerability rule for yet? And then, is this a type of tool that we have to install and run, or can we do it as a software as a service solution? Right? There's some trade-offs and costs there. The capital solutions, obviously, there's usually more upfront, maybe less ongoing, depending on support costs. But the service ones are less upfront and maybe a little more ongoing, depending on support costs. Usually, the reason you can't do the other is maybe your organization says we can't work with like cloud providers. Okay. So just be aware of that. And then can it actually scale well to your number of applications? Some of these tools are really great if you're working with 10 apps and horrible if you're working with hundreds, right? So take that into account. And then this one is huge if you're talking about numbers. Can it work with your SDLC? If you have continuous integration, can your testing tool hook into that? Can I kick off a scan every time I have a new build? That's huge. Can I send my bugs, my security bugs, to the same places the developers go to consume other bugs? Can I get them in my bug tracker? Again, very big deal for adoption. They don't want PDF reports. They really, really don't. It's not fun to work with. And then what can you do with the metrics? Does it already have all the kind of metrics you want to get, or do you at least have like API access so you can get them in a programmatic way? And because of what we said earlier, can we customize the fixed recommendations at least to point to our canonical resource, if nothing else? These are all questions that are important beyond just how much is it finding, because these operate and affect what you're doing operationally. And if these are bad, you're going to spend a lot of time managing the tool instead of fixing bugs. And that's not where you want to spend your time. You want to be reducing risk. So with this, when you're getting the tools, like I said before, onboard just some test apps, some pilot apps, hopefully ones that are in development because it's easier to fix. Apply to that new development stuff first and then work on your backlog. If you try to bite off too much at once, you're going to have a bad time. And then this is controversial, but use the testing process, whether it's manual, dynamic, static, something else, that is appropriate for the type of issue you're looking for. And here it is, you're going to yell at me for this, but if you're spending your time manually looking for blind SQL injection, you're wasting your time. A lot of times you can find all your bad SQL statements with static analysis in the time you can mess around with a handful of blind SQL injections via manual test. Are manual tests bad? No. And in fact, sometimes maybe that's the only way you can do it. But if you have other opportunities, use the tool that's best for your job. Like I said, dynamic's good at finding some things, static is good at finding others, manual testing, pen testing, and design review are good at finding others. So focus, if you're doing multiple of these types of tests, focus the time with them on the vulnerabilities that they're most consistent and easy, good at finding, right? And integrate these assessments in different ways. So if you can build it again into build server and QA environments and things like that, do that. But also look at periodic reassessment. We know that if there's new development, we'd catch it in a system like that. But what happens if a year's gone by, there hasn't been any development, but we know about a new vulnerability? So you want to have a loop cycle where you can get things back into the process on a periodic basis. And you can use that risk data to tell you how often. You know, maybe a critical app is more often. Okay, here's where I'm going to talk vendor management for just a little bit. It's just kind of an intro. Because it's really a whole nother talk if we get too far into it. But even if you have no development yourself, you're getting software from somebody, so these things still matter. Basically, you want to start to approach getting your vendors to follow similar types of processes that you are internally, right? Now, you can do that by just asking some questions, which somebody earlier said they lie. I don't remember who that was, but okay. So maybe that's not a great way. You can bring that up a level to attestation, right? There are certain types of tests you can have done and signed off on. Even better is you can use a third-party verification service. So like if you're doing a certain type of static testing, you can have a third party do that with them and send you a report to see if it matches your rigor. Or you can actually sometimes directly implement some of these issues with them. So again, discovery is very hard. Inventory will be bad. If you have an organization of any size, you probably have apps you don't know about that aren't on your network. At Rackspace, AWS, Linode, things like that. So look for subdomains related to your organization. Look for words related to your organization. And look for those outside your normal IP address ranges. I'm not telling you to attack anything. Please don't do that. But look to see what's out there, because marketing will buy things. Business might be doing things, and they pop up. Or maybe they came in a merger and they didn't get into your IP list or whatever. So if you're of any size, you may have apps you don't know about. So find out about those and get them into the list. Another way to find your third-party apps, talk to contracting, legal, finance. They know who's getting paid and what the rules are. So that's another way to find out where some of that third-party software is. There's kind of levels on this too, like commercial off-the-shelf software, there's really not much you can do with. You don't have a lot of control over that relationship. You probably have to go lower on that stack of questions we talked about, like just asking questions. But if it's customized software for you, you have a lot more leverage. So you can work with them to implement more of these things. Or it might be actual contracting working directly for you. And in those cases, you can probably treat it exactly like you would any of your own software. Right? Use all the same processes. So when you're planning these and talking to these vendors, you probably have to have them grow with you. They're not going to do more than you're already doing. Because they'll say, are you doing it? And you'll say, no. And they'll say, well, we won't either then. Why are you going to hold us to a higher standard? Or they'll say, fine, we'll do that. We want $1 million more per day. Or whatever it is. So just be aware of that. And you really want to work with those folks I talked about earlier, to get these working, contracting, vendor management, legal. Because if you don't build it into the relationships you have with these folks, you won't have any leverage to get things fixed or get things fixed without spending an arm and a leg. But if it's built into the contracting, then you can get it done. So that's an important piece of that if you need enforcement. So let's talk about managing all the vulnerabilities. We had all these different ways of doing testing, of doing threat modeling, stuff like that. How do we get things fixed? Because it doesn't help to find issues if we don't fix them. I recommend aggregating and pulling together as much as what you can. If it's related to software or application security, get it in your scope. Could be from an audit third-party test, compliance, or your actual normal testing activities, get it together if you can. There are aggregation solutions you can use, like with ThreadFix or Risk.io, or you can roll your own internally, but I really do recommend seeing all that in one place, because then you can get the metrics with it, you can report it well together, etc. And again, once you have these issues, just focus on the most important stuff first, like the high-risk issues with high-risk apps. If you send like 900 issues to somebody to fix, they're done. They're out, they're going to fight you, they're going to try to get around it. Start with important things on important apps if you want to make this successful. And again, as you start to do like SLAs, like timelines on when things need to be due, again, start simple, right? We're going to just have timelines for maybe like critical issues on critical apps. Build out from there, knowing what timelines are reasonable for your organization, because you already did your pre-work to see how you do development and what works and what your tool set are and that kind of thing, right? So roll it out in phases. And then as soon as you have rules like SLAs, then you have to have a way of tracking when the rules are broken, exceptions, right? So you have to roll that out too. If you say you can't go into production with a high issue, eventually the business is going to say, too bad, this is too important, we go out of business if we don't put this in. What do you do then? That's when you have to have an exception process. How does that get documented, noted, and saved so we can follow up on it later? Because it will happen. There's a big set of trade-offs when you're doing vulnerability management between what I would call simplicity and detail. You're going to make decisions on this based on your staffing and money, essentially. But for example, the way you track dates, the simple way is just say like when a tool or process found it is when it was found. When we didn't find it, it's gone. Or you might say, no, it's actually when we reported it to them and then when it was pushed into prod as a fix. Right? So that second way is more detailed and more accurate and more fair in a way, but there's a lot more overhead with it. And this is going to be a pattern through the things here. You might also say, when I find a vulnerability in your application, there's a security bug in your application, you're gonna push fixing of that. Even if it's an infrastructure issue or from third-party code or someone else's app that you hook into, that's the simple way of handling it. Like you own the app, so therefore you have the influence to get it fixed. The more complicated way is to have like a reassignment structure, right? Again, a little more detailed, a little more fair, but a lot of extra overhead. So you have to make that decision. And then again, with exceptions, you can handle it within your system or not. And then, do you want to treat new development and all the backlog stuff with the same rules? Or do you want to set up a complex system where you handle both? Right, so you can see I kind of favor the simple system, especially if you have a large number of apps, just because it means you can spend more time on fixes and finding rather than managing the system. So I favor the simplicity, but if you have a lot of staffing and money, you can do that more detailed approach. Does that part make sense? What I'm getting at there? Okay. We're getting close here. So let's talk about the metrics and tracking. So this is, metrics is knowing how you're doing, what you need to do differently, and that kind of thing. And the metrics should impact your program and impact your resources, right? Because as you see things, they're going to alter each other. So there's a few core metrics that are always good. Maybe always is too strong a word, but they're usually good, regardless of what tools are saying and that sort of thing. One that's really nice is what we call mean time to remediate. So when you have a security bug, how long does it take to get fixed? That's a really nice metric to have. We talked yesterday about defect density. So in an app, how many security bugs are there per size? Another is if you have implemented SLAs, like certain types of bugs need to be fixed in a certain amount of time, are they fixing it that often? And how often are they meeting that rule? And then open exceptions. So we talked about there can be exceptions. How many of those do you have? Now what's important with these metrics, if you can, is to slice them and dice them at different levels. App level is obvious, right? We know for this app what the stats are. But if you can bring that up a level to the team that owns it, then you can see across teams what that looks like. And if you bring it up again to like the business unit or that sort of thing, then you're getting even better. And the point there is then you start to see those comparisons. What's going different in different teams? they have a little bit of friendly competition then. There's some peer pressure and man. Or you need to enhance it, or you need to make something new available, right? So if you see cross-site scripting all the time and it's going up even, you need to take action on cross-site scripting. Maybe you're implementing something, maybe you're changing your resources, but it tells you that, right? So you're looking for those things that are common weaknesses or trending up to know what you need to change. And you really want to automate this. If you're pulling like spreadsheets and PowerPoints and things like that by hand all the time, you're going to have a bad time. Again, like I've said throughout this, you want to spend your time finding and fixing issues, not mangling systems. So if you get your metrics right, it really helps you to continue to improve and put your focus on those issues that are giving you the most trouble. I'm going to conclude with a few key points here and then have a little bit of time for questions to talk about any of these areas that we want to dig into a little bit more. So a lot of these points here basically say, do this or you're going to have not a fun time with adoption, right? So if you don't understand your environment, you're going to misapply things and not get off the ground very well. If you don't take a risk-based approach, then you're going to be spending your time and money on the wrong things. If you don't work with the right people, then they're going to try to avoid your process. They're going to see you as police. They're going to try to avoid you. They're going to code to the tool, et cetera. Work with those folks. They're your allies. They're trying to make things better too. And use the right tools that fit your process and the tools you already have. Don't just buy something because it's cool or shiny, or hire a service because it's cool or shiny. Make sure it fits your environment, your culture, your type of work. And use these metrics. Metrics are really valuable. They tell you what you can do better. They tell you what you're doing well, and they help apply that pressure to keep making things higher quality. And I do want to encourage you to verify your program with independent assessment. It's easy to kind of have some blind spots when you're doing it yourself. So have it checked out occasionally to say, whether it's some testing or actually looking at the program itself, having someone take a look and say, yeah, okay, you're covering everything. That's great. So any questions? All right. Thanks, everyone.